Welcome. This aircraft is about aircraft weighing. It has long been entered the cockpit and having someone spin the prop when preparing for a safe and efficient flight. Dispatchers and pilots must consider many factors, including wind speed and direction, ambient temperature, the airplane's take off weight, and center of gravity. Procedure. Weight is important for determining required takeoff landing speed for your next available climate. Obstacle clearing capability. The allowable amount of reduced takeoff thrust to extend engine life. Proper takeoff and landing speed, accurate fuel planning, and compliance with weight and balance loading limitations. In addition to weight and balance, almost specifically CG is important for ensuring compliance with CG and payload distribution. Limitations: acceptable airplane handling qualities and proper takeoff stabilized trim settings. Airplane we are doing operations. Actual weight of operations of aircraft. There's actually weight of items such as fuel, crew, catering, passengers, baggage, and cargo added to the basic empty weight of an aeroplane. CG during operations is the result of the distribution of that additional weight on the basic empty weight CG. This program will show the Boeing recommended procedure for weighing an airplane to obtain accurate basic empty weight, and basic empty weight CG will begin with an introduction to help us understand the terminology and basic concepts of weight and balance that will see preparations for weighing, including servicing or related systems, conducting an airplane inventory, moving the airplane to an appropriate location, and setting the airplane configuration. Next, we will show the weighing process using platform scale. And finally, we'll see the analytical adjustments you apply to determine the basic empty weight and the basic empty weight center of gravity. Keep in mind, this program is for training purposes only. For current and complete instructions, always see the appropriate airplane maintenance manual. Weight and balance value, any applicable regulations, and your country's procedure also. Follow this program of your weighing. Here we are taking an example of 737-700. The same general procedure is valid for all months. Major exceptions will be noted appropriately. The process we are doing to learn is deceptively simple than at putting the airplane on set of scales and adding their readings will tell you what the airplane weighs. But getting accurate and reliable readings and determining accurate CG involves strict adherence to a consistent, reliable, and detailed process. In order to fully understand this, we need to understand some basic concepts and the terminology we will use. The first term is the most obvious: scale weight. You obtain the scale weight by placing the airplane on a number of scales and adding the readings from each of these scales. Basic empty weight or basic empty weight is the weight of the airplane in its baseline configuration. Then baseline configuration is defined differently from airline to airline, but can be characterized as the weight of the empty airplane, not including those items that are likely to be different from flight to flight. The center of gravity or CG of any object can be defined as that point which all of weight of that object is evenly distributed around, or all of the forces of gravity are imbalanced. The location of an airplane CG affects how the airplane responds to control inputs and how it flies. and how the load of the airplane is carried by the airplane structure. A basic empty weight CG is the CG of the airplane when it is in its basic empty configuration, that is minus those items that are likely to change from flight to flight. We should also point out that we are only concerned with the longitudinal CG, the center of gravity, force and aft. The longitudinal location or balance arm of the CG is measured in inches after the reference datum. This datum is defined by Boeing and is different for each airplane model. It can be found in your airplane's weight and balance control and loading manual. Similarly, the location of all airplane components center of gravity referred to as the component's balance arm. Now that we know about the datum and balance arm, we are ready to determine CG in from each scale in a different number of scales depending on the mind of the airplane in which way of your 737. We use one scale under the nose gear, one scale under the main wheels for a total of 5. But for the sake of this discussion, look, consider all the main gear scales as one. You will also need to know the balance arm for the point contact between each scale and its landing gear. You then multiply the reading at each scale by the balance arm, and for that scale add the result together and then divide that sum by the total weight. Now let us look at preparing the airplane to be weighed. Many discrepancies for aircraft weighing as a result of improper preparations are there. So this is an extremely important part of the process. Keep in mind, we are going to summarize these items. So be sure to see chapter 12 of the airplane maintenance manual for specific servicing instruction. We will begin with defueling. Remove as much fuel as possible by pumping out to a fuel drug. Now make sure the airplane is labeled to the specifications for defuel provided in the maintenance manual. Note that the pitch of the aircraft may not be 0 degree. Then attach fuel drains to the sub-drain fittings. Allow the fuel to drain until there is less than 1 drip per second. Next, drain the potable water system. Remember to open the valves in the lavatories to allow the water in the lines to drain completely. Now drain the waste tanks. Next, service the following system fluids for flight: the hydraulic system, the engine oil systems, the APU oil and the landing gear fluids. Also check to ensure all oxygen bottles are serviced for flight. No. If you cannot service any of these systems for flight, you must analytically account for the weight and CG effects produced by any missing fluids. Next, we need to conduct an airplane inventory experiences. Show us the problem with getting an accurate basic empty weight often come from errors in this part of the process. So let us take a moment to understand why an accurate inventory is important. As mentioned, in order to predict an airplane's actual weight during operation, you must start with the airplane basic empty weight. But how do you know what is and what is not included in the basic empty weight? That's where the inventory list comes in and must be created. It defines the contents of the airplane in its basic empty weight configuration. One of the many documents that are delivered with a new airplane is the Weight and Balance Manual. Chapter 2 of their manual includes the inventory list, the documents, the empty weight configuration of an airplane at delivery. The airlines use this as the starting point for creating their own list. The documents their own definitions of the airplane's basic empty weight contents. Far to any weighing and inventory must be done. Our goal is to confirm the airplane's contents as closely as possible to the basic empty weight configuration defined by the inventory list. This means removing any items that are not supposed to be on the airplane according to the list, replacing any items that are missing according to the list, and documenting any differences that can be corrected beginning of the door by checking the cargo compartments. Here's an example of something that needs to be removed. Next, check E&E base. Here's an example. If something that's missing, normally we would replace the missing item, but this component is out of service and will not be returned prior to weighing. So we need to document its weight in normal location. Let us check the main cabin. Make sure all waste containers are empty, as well as galley carts, ovens and refrigerators. Also make sure the storage bins are empty except for emergency equipment. Here's an example. Something that's missing that we can replace and check later to your pockets and racks. Finally, check the flight deck. Our goal is to put the airplane in the predefined BEW configuration as closely as possible. This will minimalize analytical adjustments that will need to be later applied to the scale to weigh and to calculate the BEW. Now let us work at the location of the airplane during weigh. FAA Advisory Circular 120-27D advises that you should weigh airplanes in an enclosed building because scale readings stabilize faster in the absence of drafts from open doors, and that's the way Boeing does it for all 737, 747, 757, 767 and 777 airplanes. The building should be large enough so you can completely close the doors with the airplane and tool vehicle inside. You should control the ventilation system so that there is no air movement. In addition, the floor should be level. Note that the Boeing has no technical objection to weighing airplanes outside as long as wind energy at the times the weight are recorded is within the limits considered acceptable to your regulatory authority. In all wings, the airplane exterior should be clean and dry. Obviously, any water on the airplane will make the airplane heavier and may affect the airplane's CG. Said the leading and trailing edge flaps and slats to be either fully retracted or fully extended. Boeing recommends weighing with flaps and slats fully retracted to eliminate the possibility of damage during the weighing process. Set the horizontal stabilizer to its neutral position. Close all passenger and cargo doors and move all seat backs to their upright positions. Remove any exterior lines attached to the airplane. Finally, check that the airplane is level. You won't need to level the airplane exactly until airplane is moved onto the scales, but you want to get it closed now because major attitude adjustments with the airplane on the scales can side loads that can lead to inaccurate readings. Note that a plumb bob is not included with airplane door in the BEW. You will need to supply your own. Make sure to remove it when the weighing is complete. With the preparations ready, we are ready to begin and we will be using platform scales. Since they are the most common, there are several manufacturers of platform scales. Make sure the ones you are certified to meet or exceed the requirements of your regulatory agency. Both the Boeing and Joint Airworthiness Regulations JAR recommend an accuracy of 1/10 of 1% and only your scales whose calibration certification is current. Set up the ramps, scales, and spaces according to the manufacturer's instructions on 737. You need one step for the nose gear and one for each of the main gear wheels before taking any readings. You should exercise the scale by temporarily turning the airplane onto the scales. This system makes sure that your platforms are operating freely, giving accurate meetings. If at this point or at any point in the process the scale shows reading is that you suspect are inaccurate, investigate and take corrective actions. This could mean replacing an defective or out of calibration scales and onto the spaces. Make sure the scale is 0. According to the scale manufacturer's instructions, after the plane has moved onto the spaces, now turn the airplane back onto the scale. Once the airplane has come to the rest on the scale, set the parking brake caution. Do not use the airplane brakes to stop the airplane on the scales. This could damage the scales or into side loads on the scales, resulting in erroneous readings. Make sure to close any open windows and close the captain's and first officer's seat fully forward and close all doors as you leave the plane. Then disconnect the tow bar. Now make sure the airplane is labeled to 0 degree and for fore and aft. Note there's even a bubble label on some of the aircraft. Boeing recommends always using a plumb bob for all labeling activities. If the airplane is not labeled during the weighing, you will get inaccurate readings related to the distribution of weight forward and aft. This will change the distribution of weight on the scales and this will lead to an erroneous calculation of the center of gravity. Also, note that with 767-400ER, it is not possible to label the airplane to 0 degree. This model always requires another label weighing adjustment to be applied to the scale calculated CG. Next, measure and record the oleo extensions for landing gear with non-vertical struts on this airplane. The 737-700, that means the main game, you only measure the extension of non-vertical struts because changes in the extension of non-vertical struts causes changes in the balance arms of the landing gear. You are now ready to record the airplane weight. It's best to give required all the readings at the same time. This would be inordinating, taking the readings with at least one person at each scale. Note, some scales can connect to a computer, allowing one person to read all the scales at the same time. This method can have the added benefit allowing software tools to perform and document all required calculations. Now, after releasing the parking brake, move the airplane back onto the spaces. Wait for the scales to re-zero according to the scale manufacturer's instructions. Then move the plane back onto the stairs, set the brakes, and then evacuate the airplane as before. Label the airplane and measure and record oleo extensions as before and record the weights a second time. If the total weight of the airplane is within acceptable tolerance with the first reading, record the first readings and you are done with this part of the process. That buying acceptable tolerance for weight means 30 pounds for the narrow body airplanes and 50 pounds for wide body airplanes. Acceptable tolerance in CG means 0.2 inch in airplane CG. If the second reading is not within tolerance with the first reading, repeat the weighing for a third time. If the second and third reading do not agree with tolerance, you must investigate and take corrective actions. Errors in repeatability must be function of either having the hangar ventilation system on or variations and error in recording before taking readings, such as not removing all non-airplane equipment before weighing. What are intermittent problem before the weighing equipment is repeat weighting until two successive weights and CGs do agree with tolerance and record the first of the two readings. This will be recorded scale weight and CG that provides the basis of the basic empty weight and basic empty weight CG. To calculate the final basic empty weight and final basic empty weight CG, you will need to apply analytical adjustments to the recorded scale and CG to a carefully effective removing items that were on the plane during the weighing but are not included in the basic empty weight and adding others that were not on the airplane during the weighing but are included in the basic empty weight. All extension or retraction of the flaps and slats to their basic empty weight define positions. If these positions are different, always add drainable fuel that is to be included in the basic empty weight and adding any system fluids that were not at their full displaying levels during the weighing. Non-label weighing: if the airplane could not be labeled to a 0-bit altitude and latitude correction to 1 standard G if necessary. The final steps is to be carefully document the results. This documentation could be similar to the Boeing created weight and balance manual chapter 2 documentation mentioned earlier. Boeing recommends that an airline's documentation include final basic empty weight calculation, airplane configuration, summary location and zone diagram, aircraft weighing results and aircraft weighing checklist. In conclusion, at last finally, airplane weight and CG must be accurately known to ensure safety during all operations, both in the air and on the ground. The primary basis of an airplane's weight and CG at any point during its operation is a complete and accurate weighing as described in this video. Thank you.